So, hi everyone, welcome to Barcelona JS. As always, we have some slides prepared, so I'm gonna go really fast with the slides. And first and foremost, we're always looking for speakers. I know I say this every time. We're still looking. So if you work on something cool and if you wanna share that with the community, please reach out to us. You can reach on our GitHub if you go to github.com/BarcelonaJS, or you can reach out to me afterwards or my colleague Dimitri here. Dimitri, can you? Yes, this is Dimitri. So yeah, please reach out. We are always looking for speakers, and in order to keep the community alive, we need speakers. We need all of us to be part of the community. We can't have the same three people, going in circles. Speaking also, we're also looking for sponsors. So if your company would like to sponsor us, it would. If you'd like to host a meetup or something, again, go on github.com/BarcelonaJS or scan the QR code and get in touch. We are very accommodating. We can discuss dates and so on and so forth. And regarding today's meetup, we're gonna have, as always, two talks. In the middle, we're gonna have a raffle. We're gonna give away 2 tickets at the following conference. The first one is gonna be JS Nation. The conferences are both online and on premise. So if you win, please go. That's like a really weird. Huh? Yeah. Better. So yeah, if you win one of the tickets, either at JS Nation or React Summit, please go. If you know that you cannot attend, or you don't want to, or you're an Angular fan, which is kind of weird. So please say, and we will spin the wheel again. And with that in mind, I have a message from today's sponsor, which is Adevinta. And I'm going to play a video. And hopefully the sound works. We tested it before, but
Adevinta, sustainable commerce can be a lot of things. Making space for new things, finding and closing an awesome deal, or it can be that hard-to-find gift for your favorite person. Your second-hand choices might feel too small to make a difference, but when they happen in diverse communities and accumulate in numbers, together they make a big impact. We are Adevinta, and we believe in a world that trades better. We bring together industry expertise, technology, and a diverse culture in the online classified space. Our leading brands are reimagining commerce every day. We are connecting people to make more sustainable choices by helping everything and everyone find a new purpose. Be it said hard-to-find gift or that awesome deal, we are at every meaningful moment in your life. And while our hearts beat for local markets, our impact goes beyond borders. With every second-hand trade, we are shaping Europe and the world towards inclusive societies, a healthier environment, and thriving economies. Championing for sustainable commerce. We are Adevinta, changing commerce together.
So a big round of applause for Adevinta. And as always, if it wasn't clear, after the meetup, after the 2 talks and the raffle, we're gonna have a networking session with pizza and beer, vermouth. I had to ask, so courtesy of our sponsor for today, Adevinta. So, and with that in mind, let's welcome our first speaker, Andrés, actually, thank you, Catalan. So, yes, take it away. Yes, big round of applause.
Okay. Okay, hello everyone. My name is Andrés Alvarez, and I work in the web platform team in Adevinta, Spain as a front-end engineer. My talk is named Mission Impossible Performance Culture, and today I'm going to explain you how we improve the web performance in Fotocasa. But before getting on with the mission, let me tell you how everything started. So in September 2020, I joined Adevinta Spain in the e-commerce product team. So basically, we needed to migrate Milanuncios from being in a PHP monolithic stack to a React server-side rendering application. After 2 years, 2 good years working in the product team in Milanuncios, I got bored of doing the same thing over and over again. So I was kind of up for a new challenge. So a position was open in the web platform team. So I decided to apply. And 1 month later, in October of 2022, I joined the web platform team, giving special support to the real estate vertical. So to give you a little bit of context, in the real estate vertical in Spain, we have two main web applications, Fotocasa and Habitaclia. If you live in Spain, you probably should know them. So we use React, not Angular, and we do server-side rendering. But instead of using a fancy meta framework like Next.js or Remix, we use our own framework that was developed in Adevinta Spain all time ago. And it's more or less like Next.js or Remix, and it's focused on just allowing the product teams to ship code to production. Okay, so I remember that when I joined, the engineering director of real estate, he was, "Hey, Andres, I need to talk with you." And he told me this. So the main objective of Fotocasa is to increase our SEO traffic. And I heard that performance matters a lot. So at that point, I knew that I had a mission, but I was kind of scared, okay, when he told me that. But why? Why I was so scared? So let me explain you. I thought about a few problems when he told me about that mission. So the first one was that I had no product context at all. I was just getting started. I was a Fotocasa user though, but I didn't know all the features that it has. I didn't have that product context. So another thing is I didn't know the code base. In Adevinta Spain, we use like the same foundation for all our web applications and the same set of tools that is Sui, the one that I told you, but it was like a completely new code base to me. And of course, I was the new guy. So the real estate vertical in Spain, it has more than 6 feature teams and 15 front-end engineers. And of course, the performance problem. So I remember that my manager, the engineering director, showed me this dashboard that is Google Search Console. I don't know if you know it, but there is where you can see how your SEO is working. So there is like a performance tab where you can check the performance of your website, and it's divided in mobile and desktop. So he showed me this, and there are 3 like colors here. The green is good URLs, the yellow is URLs that need improvements, and the red is poor URLs in terms of performance. So as you can see here, there were a lot of yellow URL, and the mission was making all of them green, okay? So obviously, the more good URLs you have, the better SEO ranking factor you're gonna get. So the mission was pretty clear. But at that moment, I thought like, I just getting started. I had all these problems. This looks impossible. And then I was like, okay, let's calm down and take a step back and think about the problem that I need to face. So I thought, okay, how Google measures the performance nowadays? So Google measures the performance with a set of metrics called the Core Web Vitals. So what do they represent? What these metrics represent? They represent a facet of the user experience that is measurable in the field and reflects the real-world experience of the users. So these metrics are about the user experience. They measure the real user experience of the users. So at that moment, these were the core web vitals. So three metrics, basically. LCP, that is largest contentful pane, that it represents how fast your web loads. FID, first input delay, how fast your web responds to the first input that is made or the first interaction, and cumulative layout shift, CLS, that is how visually stable is your web in terms of layout shifting. So let me explain you a bit of for each metric. So the first one is the LCP, and here we have like a CNN website loading, and this happens when you go to the website and you hit like enter. The first thing that you're gonna see is like something that is gonna be the first contentful pane, and then suddenly things are gonna start appearing. For example, the title, and then an image. As you can see, the image is the largest element of everything that appears above the fold. So this image is gonna be the largest element in the screen. So also that is gonna be the largest contentful pane element. So the faster the browser renders this element, the better is your LCP gonna be. So your objective here, or the objective, is to render this as soon as possible. So I need to. Okay, so CLS is visual stability. Here we have an example. When you click no, I don't want to buy it, go back, and then it shifts, the UI shifts, and you click by mistake, buy. And it's so annoying. It happens to me a lot of time. And it's all about making your web stable in terms of layout shift. So before getting started with the interactivity metrics, let me explain you about the main thread, because it's really important. So the main thread, what is the main thread? So by default, the browser is going to use a single thread to run all the JavaScript that you have, to perform layout reflows, layout changes, reflows, and garbage collection. So the main thread is going to be that single thread. And here we have a small screenshot of the main thread in the Google Dev Tools that I took. And as you can see here, the first thing that we see is a task. A task is a discrete word that the browser is doing. And below that task, we see that some scripting is happening. In this case, the handler of a click event. And we see all the functions that are being executed. Okay, so now that we have clear what is the main thread and what is a task, let's review the FID. So the FID is, we're going to have here the main thread, and the FID is going to be the time from when an input is sent to the browser, let's say a click, till it can start be processed. So if the main thread is busy with a task, then the browser won't be able to process that event. And that delay is going to be the first input delay. And this only matters for the first input that is made when a user navigates to a website. Okay, but at that moment, I realized that, hold on, I read an article about Google, and I realized that the FID, the interactive metric, was going to change by a new metric called the IMP. So I thought, okay, we need to be prepared. Okay, so this IMP metric is called interaction to Spain. And as the other metrics, it has some thresholds, and we needed to reach the good threshold. So the first input delay, I was thinking about the change, and I realized that it totally makes sense because the first input delay, that metric only measures the first input. So to measure the real user experience, you need to measure the every single interaction, every single input that is made in the browser. So that's the reason why I thought, okay, this makes sense. But I needed to understand that. I needed to understand how IMP worked to be prepared to improve it. So IMP is going to be the sum of three things: the input delay, the processing time, and the presentation delay. These are the subparts of the IMP. So the IMP is going to count for every single input that is made in the browser for every single event, okay? So that's really important. So the input delay, this subpart, is going to be from when the input is received till it can be start processed. So it's this time here. So if you have a blocking task, then it cannot be start processed, and then that's going to increase the input delay. And then you have the processing time. Everything that you do in the event handler, like when you have an on-click, on key press, or whatever, that's going to be what you have here in the processing time. And the presentation delay is that normally in processing during the event handler, you do some changes in the DOM. Until you do the changes, till they are rendered in the screen, that's going to be the presentation delay. And the AMP is the sum of these three, as I said. So during the journey of the user is going to interact with a lot of elements, right? And a lot of IMPs are going to be recorded. But the one that is sent to the Google database, the performance database, is going to be the worst one. Okay, so at that moment I felt ready, but I needed to establish a plan to accomplish the mission that I needed to solve, right? And I remember this quote about Peter Drucker that it was, if you cannot measure it, you cannot improve it. So I thought, well, I remember that we have some dashboards in Datadog, like with a cron job, with getting lighthouse metrics. So I thought, okay, perhaps this could be useful, but I realized that a lot of developers, they were like, I see that the CLF, for example, is perfect in Lighthouse, but in the Google Search Console, it's not okay. And why does it happen? So this happened because Lighthouse uses laboratory data. Laboratory data is basically you running some tests in a specific environment. That's what Lighthouse is doing. But we needed field data. That is the way that Google measures performance nowadays. So I thought, like, perhaps we can just use the PageSpeed API, and that's it. So in PageSpeed, you can place a URL here, and it's going to get everything that you see here if there is data. Then you can filter, it's going to use this data is going to come from the Crux, the Chrome Web Performance Database. You can filter by mobile and desktop. That's perfect because it's what we see in Google Search Console. You can filter by this URL, the performance of the URL that you are searching, or the whole domain. But it has something that I didn't like, is that it has a 28 time frame. So it's not like you cannot query the performance for the day before, okay? And also you cannot cluster URLs. Like you normally want to, I don't know, if you have a listing page or a detail page, you want to gather all the performance information, okay? So that's what we needed. I thought, okay, but Google Search Console also provides you with performance information, but it's the same. It has this 28 days time frame, and it also doesn't cluster the URLs like we want. So we needed something else. We needed real-time data, because if we ship something, we wanted to ship something and know if it was improving the performance or getting worse the performance right away. It was so important. So we use a library called Core Web Vitals that is made by Google, and we set up this dashboard in Datadog. So in this dashboard, we had like from the router that we have, all the pages to filter, for example, listing, detail, home, the device type, and also we had all the fancy like deployment lines, colors, and so on. So it was really, really handy. Okay, but now that we have the data, that we know the metric for each kind of pages, but we don't know where the performance issues are. So we needed something else. And for that, we used another dashboard, this time in OpenSearch. And we collected every single element that was causing performance issues. So here you can see that you can filter by mobile and by the path in the router. But more important is that you have like the target of the element that is causing the issue. So it was so easy to copy paste it and look for it in the web. So at that point, I felt that we had a plan. So and the plan was start sharing knowledge with everyone in the teams about web performance, doing some presentations, workshops, and sharing stuff in Slack. Track the core web vitals like we were doing it, and take decisions based on data. And I started working alongside one of the feature team that I was attracting in Fotocasa to find performance issues and fix them. Okay, so in January of 2023, we started shipping web performance improvements. And we started focusing on LCP and CLS because we thought that were easier to fix, okay, than the interactivity metrics. But at that point, we needed a way to find easier issues in locally and reproduce them. So for that, we started using this cron extension that is called the Web Vitals extension. So you just install it, and you're going to have the core Web Vitals locally. So that's perfect if you want to reproduce a performance issue. This is an advice. You can go to auction, and then there is this property that is console login that is going to show every single thing that happens related with the core web vitals in the console. And it's really useful because it's going to tell you the metrics, and also you can expand it. It's going to give you the subparts and the element that is causing the issues. And here you have both. The thing that you need to enable, that is the console login, and of course the metrics. Okay, another thing is that you can use snippets. This is a website that a friend of mine made, Joan Leon. And here you have a bunch of performance snippets that you can copy paste to the console, or you can add as snippets in Chrome. Okay, so basically, if you go here, for example, you have CLS, LCP, and you have more interaction stuff, a snippet that you can copy paste. Okay. Okay, another thing that is really useful is the Chrome DevTools. We use a lot the Chrome DevTools to debug performance issues. For example, here I have one that is for I was debugging for the IMP. But one thing that you need to do that I think that is important is that normally the developers, we develop stuff in a really nice computer under a really nice network. So an advice will be slow down the CPU, and in some cases try to throttle the network. So to find IMP issues, I would highly recommend to slow down the CPU by 6x. And then you hit record, and then you start interacting with the website. And here is pretty useful because you're going to see the event here, and it's going to basically tell you the subparts about the IMP. And it's really important to know which is the subpart that is causing troubles, because you are going to be able to prioritize where you need to do the fix. And yeah, so basically those two things. Remember the 6x slowdown, and that in every single, this case is for the IMP, but you also have something similar for the CLS and the LCP. Okay, some advices or things that we did to improve the CLS. Okay, so in terms of images, we had a lot of images without width and height or an aspect ratio. So we try to focus on that, adding for every single image those two things or an aspect ratio. We try to avoid, we replace a lot these JavaScript breakpoints, or in React, this hook use media breakpoint or whatever, because since our application is using server-side rendering, it's really hard to tell in which device you are in server-side, in which the width and height of the screen during server-side rendering. So in this case, we just use CSS, and that's it. And for content that is being lazy loaded, remember to preserve the space, especially for advertising. We had a lot of issues because advertising, the ads are normally filled in client side. So remember to preserve the space. And if not, if the ad is not filled, perhaps you can show a placeholder or something else. So the LCP. So we try to identify the LCP element for every single page. And for that, you can use the Core Web Vitals Station, the DevTools, or the snippets that is shared. If your LCP element is an image, remember to preload it. And don't lazy load it, because if not, the priority that you're going to have in the browser is going to be low. So always preload the LCP element to be rendered as soon as possible. And optimize it. So if it is an image, compress the image and search the image for the best image format for that specific browser. Okay, so at that point, we improve all that, and now we needed to face our biggest challenge, FID and IMP. Okay, so if you look for this on the internet, you're probably going to find less JavaScript and optimize long task. Yeah, that sounds easy, but it's hard. I was like looking at the code, I don't know what to do. So here you have what we did, and it worked really well. So first things, if you are using like a UI library like React or a framework like Vue, try to avoid re-renders as much as possible, because they add scripting to your code. But not, I mean, React is supposed to be fast. Re-renders are not bad. Try to avoid unnecessary re-renders, okay? State allocation, place the state as close as possible to your components, because if you place it like too high, then when it changes, it's going to cause unnecessary renders of several components. So there are also, like, if you have states, be in mind that use them when they are truly needed. Don't, there are some that you can compute on the fly, or you can, for example, just use ref if you want to preserve a variable between renders. Look for expensive renders. So every time your application, a component re-renders, what you have in the render function is, it's going to be executed. So if it has a high time complexity, then the performance is going to be worse, because you are going to have basically more scripting. Okay, so this is something controversial that we did, and it's about UI UX changes. So in Fotocasa, in the detail page, we have the first element that we have is a big image of the real estate. So users were clicking too early to that image. So because the application was iterating at that moment, and a lot of scripting was happening in the main thread. So we thought, okay, perhaps we can tell the users blurring their image that the interaction is not, the image is not interactable yet. And we did that. And it looks like doing some kind of a trick, but at the end, it's being honest with your users that this is not ready yet. So prioritize painting. Try to avoid long tasks, and you can break the long task in the main thread by using set timeouts, or you can use the scheduler API. This basically is gonna delegate the execution of that task, of that code. This is something that you can do, for example, for the tracking. You want to prioritize UI changes. You don't want to prioritize tracking. So This is something that we made, and it was really useful. Optimize third parties, of course. So you can load them when for example, in XJS, there is this after interactive that is, you can load third-party code when the page is partially hydrated, or you can load it with this other strategy that is called lazy unload, that is when the main thread is idle, okay? And we apply many more. And if you want to know which other strategy that we applied, you can just talk to me in the networking, and I will tell you more. So we, after some months working, we realized that something was not working. So it was like we look at the dashboard, and we were almost back where we started for most of the metrics, as you can see here. So we chipped some stuff, we improved, and then we went back. And at that time, I wondered, why this is happening? We invest so much time and effort to improve the performance. And I realized about something. So more features is going to be more code, and then you're going to get worse performance. If you don't take care about performance, if you don't have this performance mindset. So at that point, I was like only working with a team. So I thought, okay, we need to work with all the product teams that are involved shipping code in Fotocasa. So, but how can we do it, right? It's not that easy. So I needed to establish a new plan. We established a new plan. This is the version 2 of the plan. So instead of just sharing knowledge with the developers, we started sharing knowledge with the product owners and the engineering managers, and showing them that the performance is important. Instead of just having this dashboard and just me looking at the dashboard and being worried, we said, okay, let's try to set the performance metrics as health metrics for the teams. And instead of working with just one team, with one product team, I started working with all the teams, and all the teams were involved of working in the performance. And what do you think that happened after? Yeah, so we made it. But what about IMP? We were like, I was in the previous one, like showing you the FID, but we were like also preparing for the IMP. We were like really, really, really red, and we improved a lot, and we have improved more, and we are in the yellow threshold right now. So we were like really happy. And what about the Google Search Console? We started seeing the change in the trend. So we started having more green URLs than yellow URLs, okay? Take into consideration that this takes more time to be updated than the other one, because the other one is real-time data. So from 16 URLs, which good core web vitals, we moved to 100% good URLs. Okay, but what about SEO? We got almost 20% more clicks compared month over month, okay? Okay, but just let me clarify something. I like to think that the performance helped a lot regarding this SEO, but we also ship a lot of SEO focused features, okay? This is like the sum of a lot of work we have made in Fotocasa. But I like to think that performance work improve a lot. So in December of 2023, we got 100% of good URLs in Google Search Console. So I remember that during a management meeting, someone said, okay, but how can we prevent web performance degradation? I was like, that's really nice question, but we were prepared. So we set up some alerts, and we try to spend some time setting them up, because the alerts that are triggered, and it's like they are fake alerts or false positives, they are gonna just cause noise, right? So we spent a lot of time setting up the alerts for every metric. And we also, of course, added some bundle size check in the PRs. For that, you have you have the Webpack action, GitHub action, and also you have a size limit action. Okay, so some takeaways. So more features, more code, more performance if you don't invest in performance culture. So all product teams should be involved, not only developers, also engineering managers, products, even analytics people, everyone, okay? Backends and so on. And I think it's about this, I mean, as a solo person, you cannot fix the performance of a web application that is maintained by several people. All people should be involved, so it's a change of mindset. And that's it. I hope you have liked the talk. Here you have my Twitter account, my GitHub. I do a lot of open source. For example, the size limit action that you saw and the maintainer. And I have a bunch of stuff in GitHub. Okay. Yeah. Thank you so much.
Thank you for the talk, Andres. And now, if you have questions, yes. You raised first.
Thank you. Amazing talk. What you did makes me really happy. Do you know what made the difference? You said involving all the teams finally made the dashboard move into the right direction. And before you were only working with, what was it, the front end team?
Yeah, I like Fotocasa. It has like more than 6 feature teams, and each feature team it has some front-end engineers. So I was only working with one feature team, and the other ones weren't involved. So they were shipping code without taking into consideration the performance.
Okay, so this was everyone front end, but you only worked initially with one front end team.
Exactly. Yeah.
Okay, cool. Thank you.
No worries. Thank you.
Hi. Just related to bundle size, I was wondering if there was anything special you did with, for example, third-party libraries and trying to reduce that load.
Yeah, this is something that we did. You know that in Webpack you have Webpack bundle analyzer, and also think if you have a library with size limit, you can check the bundle size. So we try to find for quick wins, but it's really hard. Like it's really hard to make the bundle size remove stuff from the bundle size. It is being used. You can challenge. Perhaps we found some duplicated code. I remember. But yeah, I think that most of our work wasn't focused on reducing the bundle size. This is something that we try, but it doesn't impact that much. Like, I think that it's more important doing the other thing than just the bundle size.
Right. Right. You mentioned there's a trade-off between adding new. The screen flickered off. Okay. You mentioned there's a trade-off between adding new features and focusing on performance. Did you pay any attention to how much speed trade-off you had to do between like going faster and going faster?
Okay, okay, I get it. Well, I will say that the teams started looking at it when they were developing features, but it's something that we are working on it. So I wouldn't know how to answer you right now. Like, yeah, we have invented time, invest on extra time, but I don't know about the trade-off, you know? But of course, there is a trade-off because if you develop something new and you take time to measure that everything is in place and work fine, yeah.
Hi. Hello. Amazing talk. About the useless re-render, did you thought about putting some state manager like Yotai or Justan, whatever? And another question, and then I finished. Did you thought also about moving expensive logic inside a web worker?
Okay, the first one, we don't use like a state management library because most of our state is like handled in the page. We only the themes that we share across pages is the authentication, and that's it. So we mostly focus on like trying to allocate the state as close as possible to the component where it is being used. And also, yeah, that's basically it, I would say. Yeah, we didn't use it because we didn't have something like Redux or something like that. And about your other question, yeah, we thought about that, but we haven't tried. And we have some colleagues from Subito that tried, it's like the Wallapop in Italy, and they tried that and they had great results, but we haven't tried that.
So, sorry, we after the talks, we're gonna have a networking session, so you can reach out to Andres and ask more questions, and maybe he can give you like a more in detail answer. So we need to move along. So big round of applause. Come on. And yeah, just reach out after the. So now, as I said, we have a raffle. We're gonna go give away 2 tickets, one to each of the conferences. They're both taking place in Amsterdam. We have a discount code, a 10% discount code that he didn't put in the slides.
It's easy. Barcelona JS 10. So Barcelona JS 10 for the discount for 10%.
Okay, so Barcelona JS, easy to remember, for 10%, 10 after the Barcelona JS. So the way this works, we added everybody's names here in this wheel. We're gonna spin it, and a name will be selected. And if that person is not in the room, we're gonna rinse and repeat until we hit somebody who's in the room. And again, if you don't want to go, or you don't think you can go, please tell us and we're gonna spin the wheel again. Okay, so I know him and he's not here, so he's on paternity leave. His excuse is really good. Actually, I'm gonna take a picture for this. I'm gonna send it to him after. So we're gonna remove him and Eva. Wah, 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 wah. Jesus Soros. Okay, can you please talk to? Sorry, you don't want it. Sorry, I'm just gonna go. I'm just gonna play this.
Oh, there's website.
Yes. Javier. Javier, really? It. Aitor. Sorry, I'm just gonna keep going. Yeah, just eventually. Armando Medina. Armando Medina. Good. Okay, we're just gonna do stat trombone every 3, so we're gonna move faster. So Mariano. So the thing is, yeah. Luis, do you wanna go? Okay, yeah. Applause for Luis. Thank you, maybe no. So please give your details to Dimitri. So, yeah. No, this is full. So we're gonna go for the next, which is the React Summit. So let's start with the happy trombone. I don't know if there is a happy one. I'm gonna look it up afterwards. Anna? Is there an Anna? Is there an Anna who doesn't work for Adevinta? Tomislav? Okay. Remove. Keep going. Mihail? Give your... Okay, so this is done. Finally, it took much longer than I expected, to be honest. Like a lot. But let's welcome our second speaker. So, Ivan, round of applause for him. And don't forget to turn on.
Don't forget what?
To turn on the mic.
Oh, you need to do that.
Yes.
How do I do that? Where do I press?
I think so. See something?
Testing. Anybody using Angular? Nope. Good.
Oh. Okay.
All right. Hi. Last 10 years of React performance is what my talk is kind of going to be about. So, all right, who here has ever used React 18? Nice. What about 17? 16? 0.14? I think that was my first one. 0.13? Wow, all right. 0.3? I do not believe you. Well, so React has been around for 10 years. Over these 10 years, it went through a lot of APIs. Some of them improved composability, some of them directly aimed to improve performance. But today, I want to talk about the improvements that most of the developers didn't notice, that I didn't notice for years. Improvements that React flipped under our noses to make our apps faster. In other words, I want to talk about the invisible hand of React. And to start, let's talk about use effect. Who here uses use effect? Who loves use effect? One person. Well, all right. Well, I don't love use effect. Most people I've talked to don't love use effect, but I'm going to show you one reason why use effect is actually a pretty good hook. So use effect is a hook that lets us synchronize things, right? We can run some logic when some props change, when some state change, or on every change. Before use effect was introduced, the same thing was achievable with lifecycle methods. You would have a class component, a component that's written as a class, not as a function, and that class would have a render method that returns the JS6, and methods like component.mount or component.update that would allow me to synchronize to prop changes just like useEffect, but with more lines of code. So when React 16.8 came out, useEffect pretty much replaced component.mount because it was just so much easier to use. And that was a good change, but alongside that big, nice development experience change came a much more hidden but very intentional performance change, which eliminated a whole class of performance issues, and which I would like to talk with you about. And to talk about it, I have a quiz. So I have this React component. This React component renders a button, and also during rendering, it sets document body background color to red. Also, when this component mounts, it sets the document body background color to blue. So my question to you is, which colors will the browser render? Option A, red then blue. Option B, blue then red. Option C, only blue. And option D, only red. Who thinks it's A? Who thinks it's B? Good. Who thinks it's C? Who thinks it's D? All right. Well, the right answer here is C, only blue. Now, I have this code. This is the same component, but written to use useEffect. Which colors will the browser render here? Who thinks it's A? Who thinks it's B? C? D? E? No. All right, yeah, the right answer here is indeed A. So with component.mount, the right answer is only blue, but with the useEffect, the right answer is red, then blue. This difference is a result of very intentional performance decision that drove useEffect designed and helped React to fix a whole class of performance issues. But to understand this difference and to understand the issues it fixed, we need to take a detour into how browsers render things under the hood. So browser rendering pipeline is complex. But I'll be talking about this stuff who has already seen this before. Right, good. Yeah, good. There's not too many heads. So browser's rendering pipeline is complex, but we need to know only two things about it. So first, whenever the browser reacts to something, maybe a timer, maybe an event listener, maybe whatever, it always goes through 4 stages. First, it runs the JavaScript. Then, if the JS has updated the page, the browser recalculates the styles and recalculates the layout. And then, once that's done, the browser paints the results on the screen. That's the first fact, always 4 stages. The fact two is that browsers use a lot of caching. Every time the layout updates, the browsers cache it and remember it until it needs to update the next time. So for example, if you render the app for the first time and the browser calculates that the height of the header is 200 pixels, the browser will remember that and keep that in memory for as long as needed until you say click the header and the header expands and becomes 500 pixels in height. So that's the second fact. So when you have, for example, a button ref in React and some JavaScript code tries to read the height of the button, the browser would not compute the height right as you access it. The browser wouldn't need to go and compute the height when you read client height. The browser would just go and read it straight from the cache. Now, my question to you is, what happens if the button which height you're trying to read is not yet in the cache? What happens if you inserted this button straight in the same block of JavaScript and the styles and the layout were not recalculated? How would the browser know its height? Yeah. Yes, exactly. The answer is the browser will be forced to recalculate the styles and the layout ahead of time the moment you try reading them. So the moment you read the height, the browser will freeze the JavaScript, compute the styles, compute the layout, take that height, and then return the height back to JavaScript. This is a performance issue that's called a forced layout recalculation, and this was a pretty common problem with component.mount. Say you have a component that looks like this. It's a button component, it renders a button, and then it checks that if a button is taller than 300 pixels, it does something. And it uses component mount. With component mount in React, component mount would run right after render within the same block of JavaScript. So if component mount needs to read from the layout, like here, and if the layout isn't cached, which is pretty common because render does what? Render updates the DOM, which throws away some of the layout caching. If the layout isn't cached, and if component mount reads from the layout, then what would happen? The browser will have to do a forced layout recalculation, which will freeze component mount until it completes. This is a common issue, and this is a common enough issue that you can see it even in DevTools. The DevTools, if you ever do a performance recording, if you try to look into what's happening in DevTools, you might often see this layout rectangle with a text that says forced reflow is a likely performance bottleneck. And what this means is that whenever you see this rectangle, the forced layout recalculation has happened. Some JavaScript read something from the layout that is not cached, and it is slow. So compare this to the component that uses useEffect. Unlike with component mount, useEffect runs not in the same frame, not in the same chunk of JavaScript, but in the beginning of the next frame. And this changes everything. Now, if I render the button first, React would render it, update the DOM, give the control back to the browser would recalculate the styles, recalculate the layout, paint the updates on the screen, and then only once all this is over, useEffect would run and would try to read from the layout. And so now when useEffect reads from the layout is already cached, right? It's been computed here. Cache is present, so no forced recalcs happen. No performance issues shown in DevTools. You'd only see JavaScript, style, layout, paint, and then a bit more JavaScript when the useEffect executes. Now, notice how none of the reasons why useEffect was introduced were about performance. When React 16.8 came out, useEffect, the reason to move to useEffect was that it was giving us a better development experience. I was able to put all the code in the single place. It was easier to do cleanup effects, etc. But when we moved to this new API, this issue, this whole class of issues also disappeared. This is one of the examples of React's invisible hand of performance. This is how React made our apps faster without us even realizing that. And, well, that's the first example. The second example, batching. And I have another quiz. So here's a button that has an onClick. And the onClick calls a function that says, that's called make document public, and this function has 4 set state calls. First, it sets is loading to true. Second, it flips the isPublic flag to the opposite. Then it makes 2 API calls. Then it sets set published at its to whatever result the API has returned, and it sets is loading back to false. 4 set state calls. The question: how many renders will this onClick cause? Sorry? Option A, 3. Option B, 4 in React 17, 3 in React 18. Options C, 3 in React 17, 2 in React 18. And option D, 4 in React 17, 2 in React 18. 4 set state calls, how many renders? Who thinks it's A? Really? Who thinks it's B? Who thinks it's C? Who thinks it's D? All right. Nice. Thank you. The answer is C. So this is happening thanks to update batching, which is one of the earliest invisible React performance optimization. And I suppose those of you folks who raised a hand for D did this because you heard that React 18 came out with like better batching, optimization called better batching. But better batching, or like batching, was present in React even before React 18. In fact, batching was one of the earliest React performance optimizations that introduced all the way in 0.4 in 2013. It changed a bit over 10 years. It did receive a big overhaul in React 18. And, well, it's another invisible hand that makes our apps faster. Let's talk a bit about how batching works. So batching is when you have several set state calls, but they result in a single render. React 18 has 2 renders because set state calls 1 plus 2 are batched and set state calls 3 plus 4 are batched. But in React 17, only set state calls 1 and 2 are batched. Does anyone know why 3 and 4 aren't? It's not a question to you, Andrew. Does anybody else know why set states 3 and 4 aren't batched in React 17? Any ideas? Any guesses? Yeah, exactly. It's a synchronous call. But to understand why exactly the asynchronous calls prevent React from batching the updates, let's see how React conceptually implements batching under the hood. So let's say I was Meta and I was implementing React from scratch. What would be the simplest way I can implement a set state call? The simplest way would probably be something like this. Whenever someone calls set state, I take that state and I perform the update right away. And from my understanding, that was more or less what React did in the very first versions. Now, React 0.4 introduced batching. The subsequent versions improved it a bit, fixing some edge cases. And so in the recent versions of React, up until React 18, set state actually started looking a little more convoluted. Here's how. So first, now, in this more convoluted, more batched version of set state, whenever you'd call set state, React wouldn't process the update right away. Instead, it would take the update, and it would push the update into a queue. Second, after queuing the update, React would check if it's batching the updates right now, and if it's not batching the updates, then it would process the update queue right away, which at this point would include only one update. But if React is batching the update, then set state would do nothing. The set state would just return the control back to where it was called from. Batch updates, by the way, is just a simple global flag that various parts of React can set to true or false. And now, if you're batching, if batch updates is true and set state isn't processing the update, then something else needs to process the update, right? Something else needs to call process update queue. What would that part be? That part would typically be the function that set the flag to true. And in most of the cases, that's going to be the event listener function. Here's how this works. So when you set some event listener on some DOM node, like for example, you have a button with onClick, right? And then click actually fires, under the hood in React, the following happens. First, React flips the batch updates flag to true. Second, React fires the callback, fires your set state listener. If the callback makes any, if that callback, sorry, not the state listener, calls my event listener. If that callback, if that onClick listener makes any set state calls, these set state calls push the updates to the queue and do nothing else because batch updates is set to true, right? Then the callback completes and batch updates switches back to false. And finally, as the last step, every event listener calls process update queue to process any updates that are currently in the update queue that set state has pushed there while batching was enabled. This is how batching works in React 17, React 16, React 15. And that's why when you have this code in React 17, only the first 2 set state calls are batched. Because when you run onClick, the batch updates flag switches to true, but the moment you await on something, your original callback, this callback, it completes. And the control returns to React and React flips the flag back to false. And so no batching is happening anymore. Now, how does React 18 avoid this issue? How does React 18 batch the updates that happen after async if there's nothing to flip the flag, if there's nothing that can set the flag to true? The trick is that there's no flag anymore. There's this is like that, I know, Asian, East Asian religious There's no spoon. I know. Sorry, I'm improvising. So with the React 18, the logic looks different. First, the global batched updates flag is no more because all the updates are always batched without any difference. Second, the event listener, now that there's no flag, simply calls the callback directly. Third, the process update queue function is still called, but it is now called in a very specific manner. Instead of being called from setState directly, now whenever you call setState, React executes promise, resolve, then process update queue. Andrew is just doing this from the sidelines. Thank you. But what this does is this runs process update queue, but not immediately, but rather at the end of the frame after all JavaScript has finished executing. If you remember this chart from like 5 minutes ago, this is how it works. You have a frame. The frame starts running on click. That on click calls setState 3 times, and setState, every setState pushes the update into the queue and schedules process update queue. It's actually only the first setState that schedules the process update queue. The second and the third one actually check if something has been already scheduled and don't schedule more functions unnecessarily, but I simplified the previous slide with code. Then on click completes, and maybe there's some other JavaScript that runs, and only after that, after all JavaScript in the frame has completed, process update queue finally kicks in and processes the queue that was collected during setState calls and applies all setState updates at once. And this is how in React 18, setStates 3 and 4 are batched. You call setState 3, it pushes the update into the queue and schedules processing, but it does not process anything right away. Then you call setState 4, it also pushes the update into the queue and also does not process anything right away. And then make document public finishes executing. Maybe there's some other JavaScript that's scheduled to execute in the same frame. It also schedules executing. And then only after that, process update queue kicks in and both updates are processed together, resulting in a single render. This is update batching. And this is another invisible hand of React that makes our apps faster out of the box. My question to Andrei or anybody else, does anyone know how to enable this, enable this React 18 batching behavior in earlier versions of React? Unstable batch updates. Yeah, so something you could do in earlier versions of React, which I didn't put into the slides because I thought they would be too long, but I'm right on time. So let's talk about that. Something that you could do in earlier versions of React is you could import. Next display. Does this work? Yes, this works. You could import unstable batched updates from React DOM. It does not work. It's a scary name. It's intentionally scary. The fact it's like one of the most stable React APIs. It's been around since like 0.14 at least, and then even before that as an add-on that you could have used. So it's even present in React 18, even though it's not doing anything. But if you're still, anybody still using React 17? 16? Sorry. If anybody's still using older React versions, then what you could do is you could use that to optimize to batch your updates. So this is updated batching. Let's talk about one more thing, which is suspense, and guess what? I've got another quiz. So here I have a bit of JS6. This is a header component with a few children. There's an icon, there's a menu that's collected by default, there's a button that opens the menu when you click it. Now, imagine this is a server-rendered app. If it's a server-rendered app, there will be a few moments when the app won't work as expected. For example, if the app is just loading and the JavaScript has not yet loaded, then the button wouldn't do anything, right? You would click it and there's no JavaScript and nothing happens. But if the JavaScript has been loaded, but the app is still being hydrated, well, this is my question to you. What happens if the button is clicked during hydration, not before hydration, not after hydration, but during hydration. Option A, nothing. The click is ignored. Option B, nothing. A warning is logged. Option C, the click is remembered and is replayed once hydration completes. And option D, the page freezes. And who thinks it's A? Who thinks it's B? Who thinks it's C? Who thinks it's D? The answer is D. The answer is D, because the whole page would freeze. The whole page would actually be already frozen at that point. Hydration by default freezes the page for as long as it takes to hydrate the whole app. If your app has 10,000 components, then the page would be frozen for as long as it takes for React to render the whole 10,000 components. All right, another quiz. This is the same app, the same question. By this time, the insides of the header are wrapped with suspense. The question is, what would happen to the page now? A, nothing, the click is ignored. B, nothing, a warning is logged. C, the click is remembered and is replayed once hydration completes. And D, the page freezes. Who thinks it's A now? I like the commitment. Who thinks it's B now? Who thinks it's C now? Who thinks it's still D? The answer is still D. The answer is the page will freeze again, but this time it will freeze for a much shorter period of time, only to hydrate the elements inside suspense, only the icon, the menu, and the button. Here's how this works. So suspense, generally, is a component that's used for data fetching, right? The idea is that you wrap some parts of your page with suspense, and when you're fetching something, suspense would render you a fallback, which is the loading icon. However, that is only one part of the idea behind suspense. A much less noticeable part of the idea is that suspense also enables something called selective hydration. The idea is described in a discussion in React 18 working group, which is like 5,000 words. So I'm not going to read all that to you. And I go in depth into it in my talk. But the gist is basically as follows. As your site or app grows, more and more parts of it are going to get wrapped with suspense. Like, for example, if you're Airbnb, maybe you'll have this search wrapped with suspense, and each listing wrapped with suspense, and some other page sections wrapped with suspense. And so what React does without suspense is when the page hydrates, React freezes the whole page. React starts executing hydration, and React hydrates the Airbnb logo, hydrates the header, hydrates the avatar, hydrates the search, hydrates the listing, etc., and the whole page stays frozen until every element on the page is hydrated. If you click something in the process, well, the browser would not be able to handle that because the page is frozen. You'll have to wait until the hydration is complete. But with suspense, React behavior changes. React will still hydrate all elements outside of suspenses in the same way as it was hydrating the page before. So it would freeze the page, and it would hydrate the logo, it would hydrate the header, it would hydrate the avatar, it would hydrate the filter. If I click the page during this time, the page will be frozen already. The React would be busy hydrating the parts of the page that are outside of suspense. But now, everything inside suspenses is going to be hydrated in a different way. React would take the first suspense, React would hydrate the suspense without blocking the page. It would hydrate a few components, give the control back to the browser, hydrate a few more components, give the control back to the browser, and so on until the whole suspense hydrates. Then it would switch to the next suspense and hydrate it in the same manner. And then the next suspense, and the next suspense, and the next suspense, and so on. And so what happens now, if I click some suspense or something inside the suspense that is not hydrated yet, what React would do is it would freeze that, it would intentionally freeze that suspense boundary, but only that suspense boundary. Wait until the boundary is hydrated synchronously, And once it's hydrated, it would take that click and it would send that to the right event listener inside the suspense boundary. So if I have this button here, for example, and I'm trying to click it and this suspense boundary isn't hydrated yet, React would select this suspense. It would prioritize this suspense hydration. It would hydrate this suspense ASAP, and then it would send that event that it's still holding to the right button. This is called selective hydration, because React selects the suspense that you're clicking to hydrate as soon as possible. And yeah, I'm not going to get into how that works under the hood because that's a whole separate talk. But this is yet another example of React shipping invisible performance improvements under our noses without anyone noticing. React's invisible hand that makes our apps faster. So use effect, batch chain, suspense, those are my favorite examples of invisible performance optimizations. There are quite a few more that I wanted to talk about, some successful, some not, but sadly we're out of time. So thank you. I'm on Twitter/X. Feel free to follow me, no pressure. Thanks.
Thank you. Big round of applause. So I think these buttons were also written with React, and I pushed them during hydration, so the whole light froze. So questions for Ivan?
Unfortunately, I'm not a performance consultant anymore, otherwise I would help you.
Yeah. Oh, I don't work here anymore, so.
Oh.
So questions, come on. Okay, Anton.
Me too.
I'm also looking for pizza.
What's going on with React 19 regarding performance and all that stuff?
Yeah, so I think I'm also looking forward to React compiler. Which is finally, well, I don't know. I'm not sure how effective it's going to be. We're going to see. There's also React server components graduating to stable. But, well, that's a whole separate subject that I'm not super familiar with yet. We'll see how it goes.
Hey, hi. Do you know how
Yes, no.
React? Do you know how React knows which component take the click handler? I mean,
Yeah. So it doesn't. It actually doesn't. Like when you click a suspense, React doesn't know what exactly you're clicking yet, because there are no, this is not hydrated yet. No event listeners are connected to the actual DOM nodes yet. So what React does is React freezes the page to the on-click event listener gets called on the suspense boundary. React freezes the page. React urgently hydrates the suspense boundary. React then checks if there are any elements inside the suspense boundary that could receive this on-click event that is still holding, and then only if there are, it dispatches the on-click event to the corresponding element. The drawback is that, well, if nothing inside has on-click, React still doesn't know this, so React is still going to freeze the page if you click this, even if nothing inside is interactive. But freezing is going to be much shorter because it's a single suspense boundary. Does this answer the question?
I mean, what happens if I click on the image, but actually also the title has an on-click handler?
Oh, so if I click on so the question is, what happens if you click the image, but the title also has an on-click handler? Right, so, sorry, I'm trying to think if I can show this clearly, but, okay, so this is a standard JavaScript event, right? When you click an image, the browser knows that you click an image. The target is the image tag. The thing is, React still doesn't know if the image has a JavaScript that has an on-click on it. So React holds, freezes the page, hydrates the whole thing, checks the event target, which is still the image, checks if that target has an on-click on it, and if yes, it calls the on-click with the event that is still holding. This answer is it still not clear?
Oh yeah, I think it's clear, but we can talk later.
All right, yeah. Any other questions? Yeah.
Yeah, sorry. Thank you for the talk. It was great. Yeah, the question regarding actually the unstable batch updates.
Could you give us an example when things can go wrong? Because like, for example, on that example, it looked like actually a good idea to use unstable batch updates. And I've seen myself, sometimes I was forced to use it to make the app, work better.
I have literally seen no cases when something could go wrong, and I know this is very rare for an API that's prefixed unstable. But generally, this is something that I would put pretty much everywhere. I have several subsequent updates, and they are not inside the event listener. Or just upgrade to React 18, which does this for you. Any other questions?
Last one.
Oh no.
Hi. What is best practice to separate to different suspense components? Like, I can wrap every component to suspense to increase speed of iteration, or I can just make it to logic blocks or something like this.
So I actually asked Dan Baron about this on Twitter/X, and he was like, well, I mean, yeah, you could totally wrap every component with suspense. The drawback is that, like, if any component suspense, it's just going to disappear because there's no fallback on the suspense. So I'm not sure if like what I'm saying is clear, but like suspense does several things at a time, and that makes it amazing/terrible. But like if anything inside here, like if you just wrap every part of the page with suspense, and then something here suspense because you have a component that's like lazy loading, the whole thing is going to disappear. You don't want that. So wrapping everything with suspense is probably not the best idea. What I'm generally doing or saying to do is pick some logical sections like here and wrap each logical sections. The smaller the better, but probably not too small. Does this answer the question?
Okay, so as I said earlier, we're going to have a networking session after this in the kitchen. Both speakers will be there, so if you have additional questions, please, or follow on Twitter, or both. So a big round of applause for. And, thank you for attending Barcelona JS, and we hope to see you next month. So.